Hi, I'm Harsh, and in this video, I'm going to showcase how you can locally test and deploy your infrastructure as code configurations using LocalStack. Infrastructure as code or ISC allows you to manage and configure infrastructure through a JSON or a YAML or a language construct rather than manually editing configurations on your servers or the cloud management console. Previously, in the old days, you'd have to go to your cloud management console and follow a tedious process of clicking buttons and achieving your desired infrastructure state. However, this ClickOps approach does not allow you to version control your infrastructure. There can always be a room for manual errors, and documenting everything end to end is pretty tedious. With ISE, you can treat your infrastructure just like your software code. However, there is one inefficiency that still persists, and that's about testing your ISE configurations reliably. As a developer, you will always find yourself battling with configuration issues, deploying and redeploying your ISE projects multiple times a day to basically get the things right, all while battling the restrictive cloud environment and the cloud cost that will simply keep adding up. If you're imagining a tool that lets you accomplish local development and testing of your ISE project, then look no further. LocalStack helps you achieve that. With LocalStack's local cloud sandbox that runs on your local machine, you can test your ISE project without connecting to your real AWS account. This means that you can build, test, and deploy your ISE configurations locally before you actually go into production. The best part is that you don't need to worry about any cost while experimenting. It's all right there on your local machine. In this video, I will showcase 5 examples of ISE frameworks that you can use to deploy AWS resources and how you can test them on your local machine with LocalStack. I will keep it short and to the point. Your time is limited and I get it. So let's get started. Let us first take a look at Terraform. Terraform enables you to define and manage your infrastructure using declarative configuration files. In this example, we will deploy a simple S3 static website using Terraform and LocalStack. Before navigating through this, you need to install Terraform on your local developer machine. After installation, you can use Terraform with LocalStack with just a little extra setup. To deploy AWS resources with Terraform on LocalStack, we need to leverage the Terraform override mechanism. With this mechanism, we can reconfigure the endpoints for the AWS provider to point to the LocalStack edge port. In this case, the LocalStack container runs on the edge port 4566, which means that the AWS provider and the individual services should be configured to use the port 4566 instead. To configure this, we have got two options. You can either use tf-local, an official wrapper script developed by LocalStack, or manually create a file named provider.tf. And in this example, we will just prefer to use a tf-local script, and we can just go ahead and install that using Python's package manager. So let us push this command, pip install terraform local. And once we do this, the requirements are already satisfied and it will install the tf-local script on your developer machine. Do remember that the tf-local essentially wraps up the Terraform CLI itself. If you have not installed Terraform CLI first, you won't be able to leverage tf-local. After installation, you can check if your tf-local script is working or not. And I'm going to do this by passing on the version flag to this to quickly check the version of my Terraform CLI. Awesome. Our tf-local script has been installed and it wraps the Terraform CLI under the hood. Let's go ahead and check what we have to deploy. For this example, I will be creating a simple S3 static website. And for this purpose, I have already created an index.html and a custom error document. And we will be deploying this through the S3's website configuration over on LocalStack itself. So let us go ahead and deploy this configuration on our local machine using LocalStack. I already have LocalStack up and running on my machine, and I just need to enter tf-local init to initialize my Terraform environment. So let us go ahead. Let us enter tf-local init. And this will start initializing the backend and the provider plugins in my case. And you can actually notice that we have a new LocalStack providers override.tf file. So let's open this and let's explore what we have right here. So you can see that we have specified the AWS provider and the region that we would like to deploy to. And apart from this, we have we need to avoid issues with routing and authentication. Hence, we have supplied some extra configurations right here. We have also specified the access key and the secret key, which is set to test so that you don't mistakenly use your real AWS access key and the secret key over here. One of the interesting things that you will notice is that we have to point the individual services to local stack, which is running on localhost 4566 itself. So you can notice that whatever services local stack emulates, all of the services are pretty much reconfigured to use this particular port so that we can send all of the AWS API calls to the local stack container itself. However, the difference over here is with regard to S3. So in case of S3, we are particularly using a virtual hosted style endpoint, which is required for this particular use case. If you don't prefer to use a TF local script for some or the other reason, you can use the same configuration right over here for the provider.tf file. So you can create that file, you can copy paste that same configuration through our documentation, and you can continue using it with the Terraform CLI itself. Cool. So Terraform has been successfully initialized. I can actually go ahead and apply this configuration right using the TF local script itself. And this will ask me the bucket name that we wish to deploy to. So in this case, I'll just enter test because I'm not actually creating any real AWS resource. So I can just create ephemeral resources using local stack, and I can immediately delete it by stopping the local stack container itself. So now that our resources are actually being deployed, it will ask us if we want to perform these actions. Hell yes, we want to perform them. So we can just type yes. And after this, it will take a couple of seconds to create all the resources on your developer machine itself. You can actually go to the local stack logs that I have right over here, and you can get to see that the S3 APIs are being fired up right now. And you can basically see that everything is working pretty well. And awesome, where we can see that our resources have been deployed. We had already specified a few output values in our outputs.tf file, and it has exactly provided us that. So we have the Amazon resource name, we have the domain, we have the name, and we have the website endpoint. The one caveat that we have right here is that you can notice this simply is that our website endpoint is test.s3 website, useast1.amazonaws.com. If you try to access this website endpoint, it won't work, obviously, because we have not deployed any real AWS resource. So in this case, you can just replace this amazonaws.com to localhost.localstack.cloud instead. So that was about how you can use Terraform with LocalStack for a complete development and testing of your IAC configurations on your machine without having to connect to the real AWS cloud. Let's go ahead and explore other IAC toolings that we can work around with LocalStack. Now that we have looked at Terraform, let's take a quick glance at Pulumi. With Pulumi, you can use popular programming languages such as Python, JavaScript, Golang, and more to define and manage your cloud infrastructure. In this example, I will deploy a serverless REST API using Pulumi with TypeScript while leveraging several Amazon Web Services features like API Gateway, Lambda, and DynamoDB. To leverage Pulumi with LocalStack, you can use a wrapper script called as Pulumi-local. If that rings a bell, it is similar to how we were operating Terraform with LocalStack using the TF local script. And in this case, you can use pulumi-local to automatically redirect all of your AWS API calls to the running LocalStack container instead of using some other manual file. If you want to have a manual file, you can go ahead and create a pulumi.localstack.yaml, which will contain all of your local endpoint definitions. These definitions, again, will point the AWS API calls being made by Pulumi SDK to the running LocalStack container instead of directing them to the real AWS cloud. Let us actually go ahead and install the Pulumi local script using pip. So I can use pip3 install Pulumi local. And after installation, you can actually run the Pulumi local script right over here and pass on the help flag to actually get to see the different options that the Pulumi CLI offers to us. If you have not installed Pulumi CLI yet, I definitely recommend you to install that so that you can easily start operating the Pulumi local wrapper script right over here. Awesome. Since we have the Pulumi local script pretty much configured right over here, we can go ahead and install the dependencies for the Pulumi Node.js SDK to work properly. You can actually navigate to the package.json file and you can get to see the different dependencies that we need to install over here to make this stack work properly. So I can push in the command yarn over here so that it can start installing all of the node dependencies. And once done, we can actually look forward to deploying our Pulumi stack on the running local stack container. I already have a local stack container running right over here, so we don't need to start that once again. And we can easily use the Pulumi local up to basically create this stack and set this on our running local stack container. So let us press enter and it will help us preview the updates, and we can actually get to verify if we want to perform this update. Yes, we want to, so we can say yes. And this will start creating our local AWS resources right on our developer machine. One interesting thing that you will notice over here is that we have this pulumi.localstack.yaml file, and it is being auto-generated by the Pulumi local script that we have installed before. You can actually get to see that we have configured the service endpoints to consume the local stack edge port, which in this case is localhost 4566. And that simply means that whatever API calls the Pulumi SDK will make, it will be redirected to the local stack right now. Cool. So now we can see that the resources are actually deployed over local stack. If you get to see the local stack logs, you can see that local stack has executed different AWS API calls for API gateway, Lambda. You can also get to see some IAM API calls, some DynamoDB setups, including creating table and all of these things. So that means our local AWS resources are now set up pretty successfully. Um, so you can work with the Pulumi local wrapper script with any Pulumi stack. It can be in Python, it can be in Golang or Java, or even Pulumi's own YAML configuration. Now that the stack is actually deployed, you will get to see that we have an API gateway URL right over here. Again, it is pointing to some real API gateway URL, which obviously does not exist because we have not deployed any real AWS resource. You can access this local API gateway URL via a local domain name, and I will link the documentation below for you to check out on how you can test this sample. Awesome. Now that we are done with how you can test your declarative and imperative configurations with Terraform and Pulumi on the local stack itself, so we can now actually go ahead and explore some officially supported infrastructure as code framework from AWS and test our configurations using local stack. We have covered Terraform and Pulumi now, so let us go ahead and take a quick look at CloudFormation. CloudFormation is the primary infrastructure as code service provided by AWS, and you can use CloudFormation to declaratively create your AWS architecture. In this example, I will show you how you can deploy a serverless container-based API with ECS and API gateway, along with various other services like Cognito, IAM, DynamoDB, and S3. With CloudFormation, you can write YAML or JSON templates where you can specify details for each of your resources and their dependencies. If you want to deploy your CloudFormation templates on local stack, you can use the AWS CLI itself, or instead use the AWS local wrapper script that essentially redirects all the AWS API calls to the running local stack container. Let us go ahead and install the AWS local on our developer machine, and we can install it using pip itself. Once the AWS local is installed, I can use it not just for CloudFormation, but for the entire local stack service integration like S3, DynamoDB, Lambda, and more. That means that CloudFormation does not explicitly require a separate wrapper script, and you can essentially operate it through the AWS CLI itself. One minor caveat that I would like to mention is that the AWS local script works with the AWS CLI version 1. Currently, AWS CLI version 2 is not supported, but there are ways to circumvent this. I will link the documentation down in the description below so that you can check it out. Cool. So now we can go ahead and we can try to deploy our CloudFormation template on local stack. You can see that we have this stack with a YAML configuration, and it defines a bunch of resources like ECS, DynamoDB, S3, and more of that. We can push this command to create a stack, and we can actually use the create stack API provided by the CloudFormation service. So let us use the AWS local CLI. We can mention that, hey, we want to use the CloudFormation service, and we can mention that we want to create a stack. So we can specify the stack name. In this case, the stack name can be ECS API. And next, we can specify the template body. So in our case, the template body is right over here. It's the cft.yaml. So we can mention it like this. And we can press enter and we can execute this command. So this command is being executed. We can now see that we have a stack ID that is mentioned right over here. And that means that our resources are now being deployed to local stack. So you can actually go and navigate to the local stack logs, and you can get to see that local stack is executing a bunch of things in the background, and it is basically setting up the entire infrastructure for us to start testing out. So local stack basically is providing an underlying CloudFormation engine that takes care of creating all of these AWS resources in a declarative manner. Once completed, we can actually check the status of the entire thing using the describe stack API. So we can actually go ahead, we can specify CloudFormation, and we can say we want to describe the stack. In this case, my stack is just ECS API. And let's press enter. So we can actually navigate through this and we can get to see that the stack status is create complete over here. So this means that our resources are now deployed and you can start testing your application. So this application is a fully fledged web application with a front end and a back end. So we have an extensive documentation for this one particular sample, and you can find that linked in the description below. Uh, so now that we have actually understood on how you can deploy the CloudFormation templates, we can move ahead and check out some other AWS infrastructure as code framework who actually use CloudFormation under the hood. In this case, I'm using LocalStack Pro. And if you're using LocalStack Pro itself, you can actually use the web application to directly copy paste the CloudFormation template and deploy the resources on your machine. For the community users, we have a local user interface, but it is limited only for public templates, which you can specify by a URL. If you want to check out our current CloudFormation support, please find the link to our CloudFormation documentation down in the description below. Let us now take a look at Cloud Development Kit. By far, CDK is my favorite infrastructure as code framework. And if you use AWS primarily, it is the best way to create, configure, and deploy your AWS resources. CDK follows similar principles as Pulumi because they both use a declarative infrastructure model and high-level abstraction to create the cloud resources. CDK essentially acts as a transpiler that converts our program written in Python or TypeScript or Golang into a CloudFormation template. In this example, I will show you how you can set up and deploy an AppSync GraphQL API along with a DynamoDB table to perform CRUD operations using CDK in TypeScript. To use CDK with LocalStack, you can use the CDK local npm package, which is a wrapper script for using the AWS CDK library against the local APIs provided by LocalStack. By now, you must have understood the principles of using a wrapper script for these kind of use cases. So let us go ahead and install the CDK local script using the npm package manager. So I'm installing not just the CDK local script, but also the CDK package. So let us go ahead and execute this. Please note that if you're looking to install CDK local in the node modules of your repository, you might encounter a few bugs. So it is always preferred to add this particular global flag so that you have a pretty seamless experience using the CDK local script. Awesome. So now that we have installed the CDK local script, let us go ahead and install the dependencies for this particular CDK stack. Everything has been specified in this package.json right over here with some dependencies and some developer dependencies. So we will install them and it will take a few seconds. Cool. So all of the dependencies are now installed and we can actually go ahead and we can say we want to build this particular CDK stack so that it transpiles the TypeScript program into JavaScript, which we can directly use. It has already been specified in this package.json right over here. So now we have this CDK stack in JavaScript instead. And now we can actually go ahead and deploy this. Before we actually go ahead and deploy this, we need to bootstrap the environment. So in this case, I already have a local stack container up and running on my machine with an API key configured. We can quickly get started by typing in cdk local bootstrap. And this command will start provisioning the resources for the CDK before it actually deploys resources on local stack. Once we finish with this whole bootstrap operation, you can now see that we are ready to deploy the resources. Awesome. So our environment has now been bootstrapped. Let us go ahead and type in cdk local deploy, and this will start the deployment process on our behalf. You will be first informed of the changes that the CDK is going to perform. So in this particular case, you need to mention that yes, you want to deploy these changes, and CDK will automatically start creating and setting up these resources on your local developer machine. If you want to test the things out, you can actually go ahead and check out the logs, and you can get to see that the CDK is setting up all of these resources on your developer machine by synthesizing the entire CDK stack into a CloudFormation template. So in this case, local stack is using the CloudFormation engine, as I have specified before, to create all the resources and set up everything for you. So we can actually go back and we can get to see that these resources are being created, and it should take a few more seconds to set up all these resources here. Awesome. So now our stack has been deployed. You can actually get to see that it took almost 35 seconds to deploy the entire stack. And this is the Amazon resource name for the stack that we have set up on our local machine. If you're using LocalStack Pro, you can leverage the resource browsers to actually go and check out the individual resources that you have deployed, such as the AppSync API, the DynamoDB table, and more of them. And you can get to start with the testing and integration of your changes entirely on your local machine. So that was it about the CDK. We can actually move ahead with the last infrastructure as code framework that we wish to cover in this video. Finally, we will take a quick look at the serverless application model. If you're building on various serverless services in AWS, you can use SAM to define the infrastructure using a YAML configuration. Under the hood, SAM synthesizes the SAM syntax into CloudFormation. Essentially, SAM acts as an extension of CloudFormation since you can use CloudFormation and SAM syntax within the same template. SAM provides you with a pretty handy command line tool, the SAM CLI, and you can use LocalStack's wrapper script, which is SAM local, to actually deploy your serverless apps using SAM over a running LocalStack container. Let us take a quick look at this example where we will deploy an event-driven architecture with SNS, DynamoDB, Lambda, and S3. The application will demonstrate a recruiting agency application with various services, such as the analytics service, the anti-corruption service, and the inventory service right over here. So before deploying our SAM application, let us first install the SAM local CLI. I'm going to use pip to handle this. And since the requirements are already satisfied, we now have the SAM local CLI installed on our machine. We can actually go ahead and we can pass on the help flag to the SAM local script. And it is going to show us the various options that the SAM CLI basically offers to us. Now that we have completed this operation, we can actually go ahead and build our SAM application using SAM local. So in this case, I'm going to pass on the SAM local command along with the build so that it starts building the entire application before we can actually go ahead and deploy this entire application over the running local stack container. This will take a few seconds, and I guess it is done over here. So that means that the build artifacts are available on .aws-sam build, and we have the build artifact present in the template.yaml right over here. So this is the entire synthesized template that we are going to use to deploy our SAM application over the running local stack container. Awesome. So now that we have get done with this, we can actually go ahead and deploy the SAM application on local stack. We already have a local stack container running using the local stack CLI itself. And what needs to be done is to actually hit the SAM local script and mention the deploy command along with a guided flag so that the SAM CLI basically guides us through a few steps that is necessary for us to deploy our entire application. So let us press enter, and this is gonna give us a lot of options that we need to configure. So we need to set up some default arguments for SAM deploy. In this case, we have to mention the stack name and rest of the options. So we can just go through that. We can keep the stack name as it is. We can keep the AWS region as it is. We want to confirm the changes before deployment. So yes, we can press yes over here. We want to create the IAM roles. So we can mention that yes, we want to proceed with that. And in this case, I can just disable the rollback because we don't need it. And I want to save all the arguments to a configuration file, which in this case should be the samconfig.toml file. Yes, we can keep the same environment as mentioned over here. And this will look for all the resources that is needed for deployment. This will start creating the required resources, and it should take a few seconds for us to get to see what are all the resources that is going to be deployed. So now you can see that our build artifacts are being uploaded. So this should take another few seconds. And once done, we can actually preview the CloudFormation chain set before we deploy this entire application. So we can see that there are a bunch of resources that is actually going to be created. So we can just say yes. And we can be pretty sure about deploying these changes because all of the resources that are being deployed, it is being deployed over the running local stack container. And if something goes wrong, we can just shut down this particular container and we can be just get over with. So in this case, the resources are now being deployed. It should take a few seconds here and there. Now you can notice that we have successfully created and updated the stack right over here. So we have the stack named as sam-app, and it is present in the AWS region, which is US East 1. So you can get to see all of the resources that we have deployed. We have a DynamoDB table, we have a Lambda function, we have a SQS queue, and more of them. And our SAM application has now been successfully set on the running local stack container. So now we have explored SAM with LocalStack and how you can develop and test your serverless apps on your local machine without having to connect to the real AWS cloud. And that right here is how you can test your infrastructure as code configurations with LocalStack. In this video, we tested 5 different configurations for different scenarios altogether, all of which were deployed using Terraform, Pulumi, CloudFormation, CDK, and Serverless Application Model. You can actually go to the next step and integrate this end-to-end test pipeline on your favorite continuous integration provider, such as GitHub Actions or Circle CI. In the upcoming videos, we will further explore how you can use LocalStack with application development frameworks, continuous integration providers, and different language SDKs. If you wish to explore more complex ISE configurations with LocalStack, check out our developer hub in the description below and join our Slack community to start interacting with the community members. I will see you the next time. Bye.